Right, we're going to look at how to work out gradients, which can be quite tricky for certain examples. So we're going to look at all these examples and find ways of identifying what we're doing. The first thing to consider is it positive or minus? So, taking this as an example, this line here will always be positive. The way to remember is you've got positive x, positive y. This side will always be a negative gradient. So when we're working out gradients, it's very important to be able to identify this. Okay, so bearing all this in mind, we now need to look at actually working out the actual gradient, which is actually a ratio. A ratio that doesn't change along the whole line. So the formula that we use for this will be gradient equals a change or difference in y over a difference in x. Now, if you want to measure a gradient of an existing line to try and find out what the formula is, there's a very straightforward way of doing this. The first thing to do, imagine you have a line, it looks like that. The first thing you do is find the best fit triangle. Now, you've got to have whole squares really on this kind of paper. So rather than making life hard for yourself, why don't you take it from this triangle, which is a bit wonky, but you can see has got even whole squares all the way down here and whole squares all the way down there, which gives us 5, 6, 7. 7 in the x direction and 7 in the y direction. So, applying that to the formula, all you have to do is put gradient equals, and it's 7, that comes from y. Unfortunately, they're the same, but we can go from this later on, over 7, which cancels out to equal 1, which is the correct gradient for the y equals x line. So that is perfect, that's how you do it. It's probably better to look at another example now, just it's a little bit more difficult. A big stumbling point is often with gradients that are represented as fractions. So let's look at that next. If you take the y equals x line, we've just found out that gradient equals 1. If you want to represent anything shallower down to this line, this x-axis here, it's going to be less than 1. So it's going to be a fraction. Every time. Okay. Now this shouldn't be confusing as long as you stick to the equation for the gradient. So, for example, let's get rid of this. If we take a gradient such as a line that goes there, if we take the best fit triangle to that line, it goes to there. That is actually supposed to be on that line, by the way, not over. This is my drawing. And there, we've got ourselves two clear x and y readings. So if we say g equals y is 1. That's the y direction there. 1 all over 5. So that is a gradient of 1/5. Simple. Okay, what happens when it's a negative gradient? Let's just flip this over now. I'll leave that one there, we'll flip it over. If we take the reflection, that's the same thing, except put the same equation, the same numbers into the equation, but the only difference is that's going to be 1 over 5 in a minus direction. You can count in a minus way if you want and plot it like that, or if you're looking at different parts of the line, it's easy just to get the ratio and just know it's minus. Okay, so that is how to deal with fractions and how to deal with fractions with minus gradients.